Okay, let's write our singularize app. To make this program work, we'll need 4 pure functions and then the main function that will put it all together. We'll have a function that singularizes a single word. We need one that will singularize a list of words. We also need to process each line in a list of lines. Finally, we will need a function that breaks up a string into lines and process each one. Let's start with the singularize function. It's going to singularize a single word, so its type will be a function from string to string. The singularization scheme is going to be very naive. It will simply strip of a single trailing s character. We'll implement the function with recursion, starting with the base case. We can do this because in our singularization scheme the singular form of a word is equivalent to taking the first character and singularizing the rest of the word behind it. And using pattern matching, we'll match the base case of an empty list. This branch of the function will handle when the recursion has no more characters left to recurse on. In this case, we are done, so we will simply return an empty list. Let's start on the second case for the singularize function. This case is going to implement our naive singularization of removing the s character. We can use pattern matching for this case as well. When we encounter a list which is just an s, we want to handle it specially. The pattern match for this is a list containing just s. Since we want to strip off the trailing s, the is also a base case for our recursion. We will return the empty list. The final branch of the function will handle the recursion. We'll use pattern matching again to pull off the first character from the list. The pattern match using the colon matches the first character of the list before the colon and the rest of the list after it. We'll also use the colon function to build the result. We'll simply start with the character matched by C, since we don't need to do any operations on it. Next is the colon function, which will be followed by the rest of the word being singularized. We complete our singularization by recursing back on the singularize function using the remainder of the word. The singularize words function will use recursion to singularize each word in a list. Again, we have the base case of an empty list, which we implement using pattern matching, and we implement the recursion using pattern matching to extract the first word from the list. We will singularize a single word at a time and use recursion to singularize the rest of the list. The singularize lines function will break each line in a list into words and singularize them. Again, we use pattern matching for the base case of the recursion and to extract the first line from the list from the rest of the list. In this case, we use the words function to break the line into words, which we then singularize. Then we join the result back together with words. The colon function will build a new list start with this line of singularized words, and the rest of the list is built using recursion again. The singularize content function will break content into lines to be singularized and join them back together. In this case, we don't need to do any pattern matching because we don't need recursion. We simply use lines to break up the content, use the singularize lines function to process them, and lines to join them back together. Finally, we get to the main function. Until now, every function in our application has been pure. We need a little bit of impurity to link it all together. We need to read the content from standard in, process it, and print it back out. We'll use getContents to lazily read all the content from standard in. The contents gets unpacked from the IO type into our binding s, as a string. We'll use the singularize content function to process the content being read from standard in. And finally we use print string line to print it out. Let's try it out.